Here's how it works in practice. Imagine a back-end engineer needs to add rate limiting to an API endpoint. They open vibe-kanban, create a prioritized issue with acceptance criteria, and drag it to the ready column. The system assigns it to an open code agent, which pulls the repo, spins up a containerized environment using Apple's container tool, and begins drafting code. As it works, claude-mem silently logs context, previous rate-limiting implementations, team-specific patterns, even that the auth service uses Redis for token storage. When the agent proposes a solution using middleware that tracks requests per IP, GStack enforces a review workflow. The change is automatically routed to a designated reviewer who inline comments on the Redis TTL value. After adjustments, the code is tested in an isolated container instance. Validating it doesn't break existing auth flows. Once merged, Goddess starts monitoring the endpoint's response times and error rates, alerting Slack if traffic patterns suggest the limiter is blocking legitimate users. This isn't a pipeline of tools, it's a cohesive delivery system. OpenCode handles the coding agents, executing tasks in environments managed by container, which provides macOS-optimized, OCI-compliant isolation. vibe-kanban coordinates the work boundary, translating human intent into agent actions and maintaining visibility through Kanban boards. GStack embeds the delivery process itself, enforcing stages from spec to canary release, while capturing organizational knowledge in claude-mem, which persists context across sessions so agents aren't relearning the same code bases repeatedly. Goddess closes the loop post-deployment, turning operational metrics into actionable insights that feed back into the vibe-kanban board as new work items. Each component has a single responsibility, but shares a common language of work items, code changes, and observability. The system assumes you're a team with existing repos, CI/CD concepts, and some AI literacy. It doesn't replace your Git or cloud provider, but it automates the human-AI collaboration layer that typically slows delivery. There's no set up all these tools tax. They're designed to interlock with GStack's workflow, defining handoffs between vibe-kanban planning, open code execution, container testing, and Goddess monitoring. This is what autonomous delivery looks like when the pieces actually fit. A work item starts life in vibe-kanban as a Kanban board card. When a user drags a card to the ready column, the system emits a work item's created event through its REST API. This event includes a JSON payload with work ID, title, description, and priority fields. GStack listens for this event via a webhook integration, immediately forking the work item into its own workflow pipeline. GStack's API then creates a spec stage record in its PostgreSQL database, linking it to the original vibe-kanban work ID. When the spec is completed through GStack's UI or Claude Code integration, it fires a spec-approved event containing the technical requirements and acceptance criteria. This triggers open code via a CLI command executed by vibe-kanban's automation rules. OpenCode receives the spec through its generate endpoint, which accepts a JSON body with requirements and context fields. The general subagent parses this data, then invokes the appropriate coding agent, build or plan through local IPC calls. As the agent works, OpenCode stores incremental changes in its SQLite database, with each code commit linked to the original work ID. When the agent completes the implementation, it sends a code ready for review event with a Git branch name and repository reference. vibe-kanban catches this event and creates a dedicated workspace. Here, the container tool spins up an isolated macOS VM using the container run CLI command with parameters for the specific branch and port mappings. The VM's file system is populated with the repository state from OpenCode's last commit, and the application starts on an ephemeral port. vibe-kanban's web interface proxies this port to the user, allowing real-time preview while maintaining isolation. During the review phase, vibe-kanban's API accepts inline comments through its giant reviews endpoint. These are stored in a relational database with foreign keys to the original work item. When the reviewer approves, Goddess receives a deploy event via webhook. Goddess then executes a GitHub Actions workflow, through its OSH Trigger API endpoint, which authenticates using a repository-specific token. After deployment, Gaddis continuously monitors the endpoint using HTTP health checks configured in its YAML spec. Any failures trigger alerts through its Judor Alert API, which integrates with Slack via incoming webhook URLs. Meanwhile, claude-mem passively records all interactions in its vector database, creating context snapshots linked to the work.dd for future reference. This data flow exemplifies how each component handles specific concerns while passing structured payloads across well-defined boundaries. Open code owns code generation, Container manages execution environments, Gaddis handles post-deployment monitoring, and vibe-kanban orchestrates the handoffs. Stack provides the meta workflow that ties all stages together, while claude-mem maintains the persistent context required for seamless transitions between sessions. Start by standing up vibe-kanban locally to map your workflow stages: spec, dev, review, test, deploy, monitor. Create a board with columns matching Gaddis's health states: healthy, degraded, critical. Seed it with sample tasks like implement API endpoint or fix CI pipeline. Each card should auto-generate a workspace in OpenCode when moved to the dev column. Use OpenCode's build agent for coding and plan agent for PR reviews. For local development, run container to spin up ephemeral environments for each task. Mount the workspace directory into the container, install dependencies, and run linters or unit tests inside. Use claude-mem to cache context between sessions so the agent remembers the project's architecture and past decisions. If a test fails, the agent should suggest fixes based on historical patterns from the memory store. Background jobs handle async tasks, like Gaddis's periodic health checks or claude-mem's memory compression. Schedule these via your system's job scheduler or a lightweight cron-like tool. For example, every 15 minutes, Gaddis runs a DNS check on critical services and pages Slack if TTL drops below safe thresholds. claude-mem compacts memory every hour, pruning redundant observations and syncing to a central store if the team opts in. Production deployment starts with container images built from the same OCI specs used locally. Push these to your registry, then orchestrate with Kubernetes or a simple fleet of VMs. Attach Gaddis monitors to each service endpoint, configuring alerts through its API. Use Gaddis's webhook to trigger auto rollback if response time exceeds SLA. No need for manual intervention. Test the pipeline by creating a dummy task in vibe-kanban. Watch OpenCode generate code, container run integration tests, and Gaddis validate the deployed endpoint. If the health check passes, the card moves to monitor. If not, it routes back to dev with a context-rich error summary pulled from claude-mem. This MVP skips non-essentials like complex RBAC or multi-tenancy. Focus on tight integration between the tools. vibe-kanban's UI reflects real-time system health via Gatus badges. OpenCode agents consume memory context from claude-mem, and container ensures parity between dev and prod. Ship when a single task can flow end-to-end without human code changes, then iterate based on the first wave of monitoring alerts. The workflow binds together with G-Stack orchestrating stages from spec to canary, each step triggering downstream tools. You start by cloning a G-Stack template repo, then run G-Stack init to set up the directory structure and default GitHub Actions workflows. Environment variables like GitHub token and Claude API key are required for authentication, stored in .env files or GitHub secrets. For claude-mem, install via npx claude-mem install to enable persistent memory, which automatically captures context during agent sessions. This requires setting mem server URL in your Claude code settings to point to the local or cloud worker endpoint. The memory stream can be viewed by default, though this port is configurable. vibe-kanban needs a workspace directory with a kanban.json config file listing assigned agents and their access tokens. Run vibe start to launch the UI, then use vibe create issue to generate work items from specs. Agents are switched via the UI or terminal commands like vibe switch agent codex. Apple's container tool demands macOS 26.plus and installation via .dmg packages from GitHub releases. After installing, Pull a base image with container pull nginx latest. Then spawn isolated environments using container run. It rm nginx.latest bin h. It lacks Windows cards Linux support entirely, and pre-v26 macOS versions are unsupported. Gaddis is deployed via Docker, Docker run vpwd config.iml, etc. gaddis config.iml gaddis.latest, or binary downloads. Alerting requires configuring Slack, Discord, or PagerDuty keys in config.iml. The dashboard runs on port 8080 by default with SSL options for production. Licenses vary. OpenCode and claude-mem use MIT, Gaddis Apache 2.0, while Apple's container is proprietary. Self-hosting is free but requires infrastructure for vibe-kanban cloud instances or Gaddis dashboards. To start today, install OpenCode desktop app, then run OpenCode. Agent build to initialize your coding agent. How do teams handle containerized testing on non-Apple platforms if container is macOS exclusive?